Good morning, good afternoon, good evening, whatever time you may be watching this recording. My name is Edgar Cruz. I'm part of the 8 a.m. class for Chemistry Lab 1. This is my recording for lab number 3, which is the metal density problem lab. I have my workbench here. To keep the video as short as possible, I'm going to be showing the method one time for the method number 1. I did the other ones previously, so I have all the information here, which I will still be sharing here. Yeah, but just to keep the video as short as possible, because if I were to record all 3 of them, then I would add it to over 10 minutes. I'm going to need a scale, 15 ml graduated cylinder, 250 ml beaker, then some water, and metal number 1. So let me just fix this up here. Okay, so what I'm going to do is we need to find the density of the metal, and to get the density, we need the mass and the volume of metal. So to find the mass, I'm going to use the scale, my beaker on there, tear it so that the mass of the beaker does not get corded, and I'm going to pour in my metal. To make it more realistic, I'm going to use this realistic method here to pour in metal. So pour in metal. Here it gives me 49.1096. 6 grams. So now that we have the mass, to find the volume, I'm going to get water, pour some into my graduate cylinder, again using the realistic pouring method. Okay, here this is about 31.5, I'd say 35. So I'm going to record this as the initial volume of the water, 35. Okay, now I'm going to pour in all of the metal into the cylinder. Pour in everything, and now record the new volume. So this is around 2, 32, 33, 34, 35, 36, 36.1 maybe, 36.1 milliliters. So now to find the volume of the metal itself, I'm going to find the difference between the initial and the final volume, which is this volume here. So I'm going to do subtraction between this reading, which is 36.1, minus the initial reading, which is 31.5, which gives me 4.6. 4.6. Okay. Now that we have the mass and the volume of the metal, we're going to do a simple division between mass and the volume to get the density of the metal. So the mass that we recorded is 49.1096 divided by the volume of the metal, which is 4.6. And it gives me a total of 10.676 grams per milliliters or centimeters cubed. So here we check the problem. It gives us the density for silver, rhodium, and platinum. And here we have density for silver is 10.5. Here we got 10.676, which is pretty close to the 10.5. So I would say that metal number 1 is silver. Now I did the other two metals, and for metal number 2, I got a density of 11.63, which is pretty close to 12.4. Closest, which would be radium. So metal number 2 is radium. And for the last metal, I got a density of 24.4413. Here it's close to 21.45, not that close, but it's around it. So the last metal would be platinum. Yeah, so that's going to be it for my recording. Thank you for watching.